All right, so let's do this problem. This is the first set of problems from practice exam 2B. So the first thing we want to do is figure out what kind of problem we got. We see we have mu1 and mu2 right here. We can see that the first two questions are asking to identify the null and alternative hypothesis. Because we have mu1 and mu2, that's two samples, right? We also have that here, mu1 and mu2. So that means the two sample hypothesis test. So this would be a chapter 10 problem. And just quickly looking through here, we can see that we are going to be using the p-value approach for this problem. So two sample hypothesis tests using the p-value approach. The next thing we want to do is write out everything we have in this problem. So let's just read this right here. So it says from a random sample of 32. So that's going to be our N1 is going to be 32. The average training time was 75. So that means our X bar 1 is going to be 75. What else? Sample standard deviation. So that's important. I'm going to put S for sample and then SD, sample standard deviation 1. So that's really important. The fact that we have sample standard deviation. So it's going to be 12.3. Nope, it's going to be 10. I was looking at the wrong one. So it's going to be 10 right here. And then let's look at the next sentence. So in a random sample of 16, so that's going to be our N2 is 16. The average training time was 65.4. So X bar 2 is going to be 65.4. And then we have our sample standard deviation of 12.3. So SSD 2. So sample standard deviation 2, it's 12.3. Okay, so that's everything that we have. Now let's determine our null and alternative hypothesis. The way that we can figure this out is by looking right here. We can see that the keyword right here is higher. And I've said this before in my previous videos, that typically we are given the alternative hypothesis. So right here, we're given the alternative hypothesis. This means it'll be a greater than problem. So I'm going to do HA is mu1 minus mu2 is greater than, because it's higher. This word higher is greater than, and then 0. And that means our null hypothesis, H0, is going to be mu1 minus mu2 is less than or equal to, because our null always has an equals in it, and it's the opposite sign of this. So less than or equal to, and then 0. All right. So right now we can answer these two questions really quick. Our null hypothesis is less than or equal to, so that is C. And our alternative hypothesis is greater than, so that's going to be D. All right. Now, since we're doing the p-value approach, if you guys recall, whenever we do the p-value approach, we're going to be comparing our p-value to alpha. Okay. But to get our p-value, we need our test statistic. Our test statistic is used in the calculation of the p-value. So let's start with trying to get our test statistic. Okay. So this is our cheat sheet for two sample hypothesis testing. We have a greater than problem. So that would be this case right here. We want to calculate our test statistic. And you can see that this bottom part looks a little bit crazy. This is our standard error. So what I'm going to do is calculate this bottom part first, and then I'm going to calculate the test statistic after we get our standard error. So let me just move this here, and I'm going to put SE right here. And if you look at the formula for standard error, we have standard deviation 1 squared and we have standard deviation 2 squared. So what I'm going to do to make this formula a little bit easier to plug into Excel is I'm going to put SSD1 and I'm going to square that and just have that number ready. So it's actually move this here. So we're going to do 10 squared. And here we're going to do SSD2 and square that. So there we go. Now we are going to get our standard error. We are ready to do this. So it's going to be the square root of standard deviation 1 squared divided by n1 plus standard deviation 2 squared divided by n2. So that is this. So the square root of standard deviation 1 squared. So this one divided by this plus this divided by this. All right. So when we do that, we get 3.54. That's our standard error. Now that we've done this part, we can do the whole entire test statistic. This value right here is 0. That's what's usually here. And for the purposes of this class, for chapter 10 problems, so 2-sample hypothesis testing, this is always going to be 0. So we don't have to worry about this value right here for this chapter. Okay, so it's going to be x bar 1 minus x bar 2 divided by our standard error. So I'm going to put TS for test statistic. And we said x bar 1 minus x bar 2 divided by our standard error. And there is our test statistic. All right. So now that we've got our test statistic, we can go to the p-value approach, the calculation for that. All right, so what kind of test is this? You can see that this is a greater than problem, right? A greater than problem, just looking right here, means it's a right-tailed test. It's to the right. And that also means we're looking at this right here to the right. The next thing we need to identify is, do we have population standard deviation or do we have sample standard deviation? We have sample, right? That's why we put S. S stands for sample and standard deviation. Because we have sample standard deviation, we need to use this formula. 1 minus t dot dist, test statistic, degrees of freedom, 1. And if you guys remember this from the previous video that I did, you would need to calculate your degrees of freedom using the template for unknown variances. This is something that you'd be able to use on the exam. So before we can fully get our p-value, before we can calculate this value, we need to get our degrees of freedom. The way that we're going to use this or do this is use our template for unknown variances. So I'm just going to pull that up. And you would need to change these values in red, to match the values that you have here. So my N1 is 32. So let me change that to 32. My X bar 1 is 75. So let's change that to 75. My standard deviation 1 is 10. So that's okay. Let's go to our N2. It's 16. So that's already 16. X bar 2, 65.4. That's also already there. And standard deviation 2 squared, 12.3. That's already there as well. So this automatically gives us our output. So our degrees of freedom should be 25 for this problem. So I'm just going to minimize this right here and put DF, and our degrees of freedom we said is 25. So there we go. Now we have everything we need to solve this problem. So to get our p-value. So I'm just going to put p-value right here. And the formula is 1 minus t dot dist. So let's do that. 1 minus t dot dist. X is our test statistic. So there we go. Degrees of freedom. This is 25. So that's right here, comma 1 or true. And you do that, and there's your p-value. Now we need to know what our alpha is to determine if we reject or do not reject. So if we just scroll a little bit, we see our alpha is 0.01. So like I said earlier, when we do the p-value approach, we're comparing our p-value to alpha. So we said alpha is 0.1. Okay, not 0.01, 0.1. So comparing these two, we see our p-value is less than alpha. In other words, alpha is greater than p, or you can say p is less than alpha. And looking here, this rule, we have this right here, right? Our alpha is greater than P. P is greater than alpha, same thing. That means we reject. So we would say we reject our null. And now we can just go through what we just solved here and put in the answers. So for number 3, standard error, we calculated that right here. That'd be A. What's our test statistic? Test statistic 2.71, so C. P-value 0.006, so we can round that to 0.01. And we said we reject, so the answer would be A here. We reject. And that's how you do that.